Welcome back. Last time I made a huge mistake because I jumped right into a medium or I think it was hard question right after I took a long break from LeetCode. I kind of don't want to mention the website's name. It sounds like I'm kind of promoting them, but LeetCode, if you're watching this video, feel free to promote me or sponsor me. Anyways, so I think this time I should start with something easier. At least I'll start with an easy question first this time. So, well, let's get started. Okay, so paint house. Now there are a row of n houses. Okay, each house can be painted with one of three colors: red, blue, or green. By the way, I feel like last time one of the reasons I failed the challenge was because I used this retard. Never mind, I won't use that word. I used the new UI, which sucked. Anyways, so the cost of painting each house with a certain color is different. You have to paint all the houses such that no two adjacent houses have the same color. So one color, it's right next to the other. The cost of painting each house with a certain color is represented by a n times 3 cost matrix. For example, cost 0, 0 is the cost of painting house 0 with color red, and cost 1, 2 is the cost of painting house 1 with color green, and so on, and find the minimum cost to paint all houses. All costs are positive integers, so this kind of resolves some issues for us. Let's take a look at example. So we have 17, 2, 17, 16, 16, 5, and 14, 3, 9. Output is 10 because from here you have 2 plus 5, which is 7, and plus 3. So, excuse me. So 2 is probably, how did I define here? It's green, right? Let's say it's green. 2 is, so you don't actually have to care what actual color it is. You just need to remember that the index of this color cannot be the same as the next one you choose. So you have 2, and then now you jump to the second index, which is 5, and then you jump back to the first index. So 2, 5, 3, which is 10. So essentially, every time you move on to the next house, you have to consider every situation, every possibility, which is the red, green, or blue. Red, green, or blue. You have to consider 3 possibilities in order to lower the cost. So, well, right now, on the top of my head, I can think of dynamic programming. So, okay, just checking time. Because I think when we are considering the lower cost, we always look at the previous house, right? So we can just start with first house as a base, and then we'll do what's the word, induction from there. So because we only have one house, so because one color has to be different from the other for each house. So for 2 adjacent houses, that's what they mentioned. Paint all the houses such as no 2 adjacent houses have the same color. So we can memorize the cost in an array one after another. So let's do. So first we need to use this. We need to initiate the base, and then we can start the induction. So which is n last. Let's call it last r. is equal to cost in n. So this is the, let's say this is the last red color. So assign the first red color to a variable so that we can keep track of it. And then this one, well, pretty much the same. We'll just have to change the index. So this becomes last red and last blue and last green. Okay. Now, one important check is that we need to make sure that the first row is not empty, so that this won't throw exceptions. So we'll have cost.length is, if cost.length is equal to 0, or cost, or the length of the column is equal to 0, then what do? We'll return 0 here. So it's distracting. Someone just texted me. Here's the thing, I'm a very easily distracted person. This is my weakness. I need to change. So, god damn. Okay, okay, so, and then you can, now we have the base, we can start the, we have the first step. If you took any discrete math, you will know that this is called first step or base, and then you can start reduction. So for int is equal to 1, and then I is less than cost dot length dot I plus plus. So we'll start a for loop, and then we'll keep track of the current red color, and this red color is going to be comparing the current cost with the previous cost, which is math. So we'll do a comparison by doing math and math last. So we're comparing the last adjacent house, but the color has to be different. So it will be comparing blue and green. So last blue and last green, and then we'll add the so if we get the minimum from these two, we'll add the current, or add the current cost. So it is cost and I and 0, because this is red, and then just pretty much the same thing. Blah blah blah. So we'll have red, blue, and green, and the minimum is gonna be R, and this will be B and R. So, and then we'll add 1, 2. Okay, so now we have the low cost. We need to update the tracker, which is last. So last will be equal to current R, and that's basically the same thing again. So R B B G G. So okay, so now the lowest cost of that corresponding color has been updated, and we get out of the for loop. So at the end, once we reach the last house, we can compare during check-in time. When we reach the last house, we can compare the lowest cost amongst these three colors. So we'll return math minimum. So pretty much the same thing. Last B, and then last, or let's do last R and last B. Oh, not yet. We'll need to, after this, we'll need to compare another color, which is last G, and then we'll wrap it with the math method. Okay, so that's pretty much it. 4 minutes. Let's see, I'll just submit it right away. See if we have time. $10.10. Okay, so let's submit it. Okay, accepted. Perfect. All right. So yes, this is a very easy dynamic programming question. And to be honest, I feel like dynamic programming is a very simple concept, but covered by a overcomplicated name. Basically, dynamic programming is just to memorize what you did in the previous step. In this case, it's pretty easy because no colors can be the same for adjacent houses. So we only need to save one instance for each color. If they change the question to be two identical colors are allowed for two adjacent houses, then that would be a little bit difficult, I think. But that will be up to my next episode in the future. So thanks for watching, and I'll see you next time.